Okay, so now that we've done confidence interval for the mean, we're going to do confidence interval for the proportion. So going back to the example earlier, suppose you want to estimate the proportion or percentage of college students who are satisfied with the new student orientation on your campus. You could take a survey of 200 students who attended the orientation and ask them, did the orientation prepare you for your first year of college? Suppose that 124 students answered yes. You can calculate a sample estimate p-hat, which is 124 over 200, or 62%, and that's called your point estimate. When you're using sample data for estimating population data, there's a possibility that your random sample does not reflect the population, and this is called error. So in order to have a normal distribution and for this method to work, we need to fulfill the initial conditions for the sampling distribution of the sample proportion. That should say proportion. All right, let me get my annotator. Why can I not annotate? I'm not seeing a way to write on the screen, which is weird.
I don't have the presentation in front of me. Is it where we're supposed to have it?
Oh, that's probably why. Thank you. That's better. Now I can write on it because it's appearing to you. Sorry about that. So these are the initial conditions for being able to have to do the sampling distribution of the sample proportion. And this word should be proportion. So these should be familiar from chapter 8. We need to have a random sample. N times p-hat times 1 minus p-hat is greater than or equal to 10. And the sample size, n, has to be less than or equal to 5% of the population size. Now, notice number 2 is slightly different. It's using a p-hat instead of a p. In this confidence interval, we don't know p. That's what we're trying to figure out. P is what we're looking for, is we're trying to estimate. Let me say that better. We want to estimate P. We don't know what it is. So the best estimate we have right now for P is p-hat, which is our sample estimate. So that's why the formula is slightly changed and uses p-hat in this chapter. So in order to have a more precise estimate of the parameter, we will use a confidence interval with a margin of error. We write it as an interval with a lower bound and an upper bound, same as what we've done with the mean. Or we can write it as p-hat plus or minus the margin of error. So now our interval is going to look like p-hat in the center. And remember that p-hat is the sample proportion or percent. We have a margin of error on one side, which gives us p-hat plus the margin of error, which is the upper bound. And on the other side, we're subtracting the margin of error and get p-hat minus the margin of error, which is our lower bound. And that gives us the total width is the same as twice the margin of error.
So the width pretty much stays the same with the same rule of doubling the margin of error.
Yep, for the same reason, that it's just the same looking interval. And we are estimating p hat here. We could be estimating anything about the population. We might want to know about the standard deviation of the population. We just don't do that in this class, but it is possible to do that. So the width is the difference between the upper bound, lower bound, and if we know the margin of error, the width is twice the margin of error. Just another way to do it. So looking at what it looks like, the 95% confidence interval for the proportion of students who said orientation prepared them is 0.603 to 0.637, and we can also write that as 0.62 plus or minus 0.017. Where p hat is 0.62 and the margin of error is 0.017. Same thing we said earlier. And this stuff's the same as well. The confidence level is that proportion of intervals that would contain the parameter. And the opposite of the confidence level is called the significance level, that alpha. That's all exactly the same. And when we report, we say we're 95% confident that the proportion of students who thought that the orientation prepared them for the first year of college is between 0.603 and 0.637, and that's not hours. I think I did a little cut and paste in haste. Okay. We did that. And the same thing with the level of confidence and sample size. It still impacts the same way. So how do we calculate these? With StatCrunch.